What's up guys, today we'll be doing Raffles Girls Primary School Prelim Examination 2024 for Paper 1 Booklet A. Likewise, like the rest of the papers, I will not be going through all the questions, only those that I find difficult and I think that students will struggle with. Okay, I'm going to skip question 1 to 3 and move right on to question 4. Alright, let's jump right in. What is the length of the boat shown below? As you can see, the boat is not starting at the 0 cm point. Firstly, we need to find out what this mark is over here. Okay, and how do we do that? First, we want to count the number of increments we have from 0 to 1. Alright, so we have 1, 2, 3, 4, and 5. Knowing that there are 5 increments, what I want to do is to take my 1 cm divided by 5, and that will give me 0.2 cm. Now I know that every increment is 0.2. So from here, I can tell immediately that this point over here is 1.6 cm. Now knowing this information, we can see that the screw also ends at 7.2 cm. What can we do? We can take 7.2 cm minus 1.6 cm and we will get 5.6 cm, which is the answer for question number 4. Alright, moving right on to question number 5. What is 5% of 2000? Whenever we see a percentage, we want to convert it into a fraction. 5% is simply 5 over 100. And when we see this word of, what we want to do is to multiply. So we have times 2000. When we have a whole number on one side, what we want to do is to convert it into a fraction as well. And then what we can do right now is to simplify it. Cancel my zeros. And what I'm left with is 5 over 1 times 20 over 1. What I want to do is to take the numerators and multiply them together and the denominators and multiply them together as well. So I get 5 times 20, that would be 100 over 1 times 1, that would just give me 1, and therefore my answer is 100. And number 2 is your answer for question number 5. Alright, next we have a fractions question. Which of the following shows 1/5 of the figure shaded? Now looking at option 1, we have one shaded part over here and we have a total of 1, 2, 3, 4, 5, 6 parts in total. So what I can say is that 1 over 6 of the figure is shaded. Now let's look at option number 2. We have one shaded part. And we have 1, 2, 3, 4, 5. Now, it is very tempting for us to just say, oh, this is 1 over 5. But I want to tell you that this is wrong. Why? Okay, I'm just going to use a pizza analogy to explain to you. If I were to have a pizza and I were to cut it down like that and say that these are 2 slices, and then we are going to have 1 each, do you think this would be fair? So whenever we are looking at fractions, the slices of the pizza has to be equal. Alright? It has to be equal. If not, it is not fair and it is not valid. So this is definitely not my answer as well. Alright, moving right on to option number 3. I can see that I have 1, 2, 3, 4, 5, 6 shaded parts. And I have a total of 7, 8, 9, 10. So the fraction that is shaded is definitely 6 over 10, which is equals to 3 over 5. And this is not my answer as well. Now moving on to option number 4, we have 2 shaded parts over here. And a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So I would have 2 over 10, which gives me 1 over 5. And therefore, this is your answer for question number 6. Okay, moving on to question number 7. Which of the following is not a net of a cube? This question requires us to have a bit of visualization to be able to see how the net is being folded into a cube. what I'm going to do is to draw it out so that you guys can see it clearly with me. First things first, I want to label each part of the net. So when I fold it up and when I draw it, y'all will be able to see exactly where these parts are going. So first thing, I have number 1. I'm going to put number 1 on the floor like that. Alright? So if this is number 1, number 2 will be folded up to be a wall behind. Number 3 would be at the side over here, if you can see that. Number 4 definitely in front. And number 5 will be folded in with number 4 to be at the back over here. Right? But if you realize when I fold in number 5, number 6 will be at the back. Right? And it will overlap with number 2. So, this answers the question. Number 1 is definitely not a net of a cube. And number 1 is your answer for question number 7. But before we move on, I want to show you that the rest of the nets will in fact give you a cube. Alright, so I will do the same thing as I did with number 1. I'm going to number each part of the net and fold them up over here. So for option number 2, I have 1, 2, 3, 4, 5, and 6. Okay, number 1 being on the ground like that again. Alright, and number 5 will definitely fold up over here. Number 6 would be on top. Alright, 2 will be at the front. 3 would be at the side on the left. And 4 definitely behind once it is folded over. Alright, so this is definitely a cube. Looking at option number 3, likewise, 1, 2, 3, 4, 5, and 6. 1 would be on the ground. 2 would be at the back. Right, 3 would be at the front. 4 right beside. 3, 5 at this side over here. And 6 will cap at the top. So, option number 3 is also a cube. Alright, moving on to option number 4. I've got 1, 2, 3, 4, 5, and 6 again. Having 1 at the bottom, 2 will be in front, 3 at the side, 4 will be right beside 1 on the left, 5 being behind, and 6 capping it up at the top. Alright, so 4 will also be a cube. So number 1 is your answer for question number 7. Alright, I'm going to skip question 8 and move right on to question number 9. Right here we have an angles question. Let's read it together. ACDF is a parallelogram. This is sentence number 1. I want to mark it down. Alright, so where is my parallelogram? ACDF. So what I can do from here is to mark out that these are parallel. Okay, let's look at the next part of the sentence. It says that BED is an equilateral triangle. BED, I'm going to highlight it as well, right over here. Okay, and when we have an equilateral triangle, what we can say is that all sides are the same and every angle inside is 60 degrees. Alright, moving on to the next sentence. It says that angle AFE equals to 68 degrees. Now, what is the question asking us? The question is asking us to find angle BDC, which is right over here. Alright, how do we tackle this question? First, we have to understand the properties of a parallelogram. Alright, whenever we look at a parallelogram, we have to know that the opposite angles are always equal. So if I have AFE as 68 degrees, what I can say is that angle BCD right over here is also 68 degrees. Next, I want to use the concept that we call Z angles. Whenever we have a set of parallel lines and a line that intersects between the two of them, right over here, BC, BD, and ED. Alright, I know that the alternate angles are equal. What do I mean by that? What I'm saying is that this angle over here, angle BDE, is the same as angle CBD over here. And therefore, this is 60 degrees as well. Using the concept of sum of angles in a triangle adds up to 180 degrees, I know that I can find my angle BDC. Alright, angle BDC would just be 180 degrees minus 60 degrees, right, over here, and minus 68 degrees over here. And that would give me 52 degrees. And this is your answer for question number 9. Alright, moving on to question number 10 and 11. We're going to look at question 10 first. A group of senior citizens was asked in a survey to choose one game they enjoyed from Uno, chess, toss a ring, and bingo. Alright, so we have 4 games over here. Now let's look at the next sentence. It says the table represents their choices. Okay, so we have 5% for Uno, 15% for chess, 25% for toss a ring, and we don't know the percentage for bingo. Let's look at the question that is posted below. What percentage of the senior citizens chose both chess and bingo? So we are not looking just at one game. We are looking at the games chess and bingo. So we gotta first find out what bingo is, right? Because currently we have a question mark. What we can do is to take 100%, subtract the rest of it, minus 5%, minus 15%, minus 25%. And I know that my answer would be 55%. So I want to remind you guys, this is for bingo. Okay, but are they asking us for bingo? No, they are asking us for both chess and bingo. So what we want to do is to take 55% for bingo and add 15% for chess. And that would give me a total of 70%. And this is your answer for question number 10. Okay, moving right on to question number 11. The choices enjoyed by the senior citizens were also represented by a pie chart, but the names of the games were not shown. Alright, this is my sentence number 1. Moving on to the next sentence. The number of senior citizens choosing one of the games was 30. So what we can do is to try to figure out which game represents 30. Let's look at the last sentence. It says, how many senior citizens took part in the survey? Okay, so what we are looking for is the total number of senior citizens that took part in this survey. Alright, right off the bat, when I look at my pie chart, I notice that there is a 90-degree mark that I'm going to label in red. Knowing that this portion of the pie chart is 90%, I can confidently say that this is 25%, because 25 over 100 equals to 1 over 4. And 90 degrees is a quarter of a full circle. Alright, so 25%. Looking back at the table, we can see that toss a ring is 25%. So this portion is definitely toss a ring. So knowing that bingo is now 55% and is the biggest percentage among the games, right? I know immediately that bingo is the biggest one over here, being 55%. Alright, and let's compare the last two. Okay, we have a smaller one and a slightly bigger one, which is our 30. The smaller one, I'm going to immediately put it as Uno. Why? Because Uno has only 5% and it is the least number among the games. Okay, so that being said, 30 has to be chess. Now, looking back at the question, how many senior citizens took part in the survey? Knowing that chess equals to 30, and chess is also 15%, what I want to do, right, is to find out what my 1% is. Okay, so how can I do that? I'm going to take 30 divided by 15%. Okay, and I will see that 1% is actually 2 senior citizens. And from there, what I can do is say that 100% equals to 1% times 100, which is equals to 2 senior citizens times 100. And therefore, my answer for this question is 200. Number 3 is your answer for question number 11. Alright, moving right on to question number 12. We see a table. Okay, so we have box A and B. Number of markers in box A is 100. Number of markers in box B is 200. Percentage of markers which are red in box A is 6%. And the percentage of markers which are red in box B is 9%. Alright, the question asks, what is the ratio of the total number of red markers in box A and box B to the total number of markers in box A and box B? Alright, right off the bat, I want to note down that the total in A and B equals to 300. Now, what I want to do is to find the number of red markers in box A. What I can do is change 6% to 6 over 100. And likewise with my 9% equals to 9 over 100. Now, let's look at box A. For box A, we have 100 markers, but what we want to do is to multiply it by 6 over 100 to find the number of red markers we have in box A. Alright, so we have 100, we want to make it into a fraction, cancel my zeros on both sides, and what I'm left with is just 1 and 1. So I have 6 over 1, which is equals to 6 red markers. Alright, and as for B, I have 200 multiplied by 9 over 100. Right, so likewise, I'm going to change my whole number into a fraction, cancel my zeros, and what I'm left with is 18 over 1, which is equals to 18 red markers. Alright, knowing that I have 6 red markers in A and 18 red markers in B, I want to add them together because the ratio that we are looking for is the total number of red markers in box A and B to the total number of markers in box A and B. So what I have would be red markers is to total markers. Red markers, I'm just going to add the two together. 6 plus 18, that would give me 24, is to the total number of markers, which is 300. Simplifying this, what I want to do is to divide both sides by 12. And what I'm left with is 2 is to 25. And this is your answer for question number 12. Alright, moving on to question number 13, we see that we have an area question over here. Let's read the question. The figure below is made up of 6 identical rectangles. Alright, this is my sentence number 1. Alright, let's look at sentence number 2. It says, find the area of the shaded triangle. Alright, so this is my shaded triangle over here. Okay, so first things first, what we want to do is to write down the formula of the area of triangle. Alright, so area of triangle is always equals to half times base times height. We want to first identify the base. What I'm going to do is to take this 24 cm as my base. And when I look at this triangle with this as the base, right, I can tell that my triangle is a mountain triangle. Whenever I am dealing with a mountain triangle, I want to know that the height is inside the triangle. Alright, in this case, is from the lowest point to the highest point, which is over here at a 90-degree angle. So, knowing that this is 24 cm, can I find what is the length of 2 of these? What I want to do is to take 24 cm divided by 3. Alright, and that would give me 8 cm. Right, why do I do that? Because I can see that it is broken up into 3 parts. Over here and over here. Are you understanding? And that is the same as from here to over here, which is the height of my triangle. Now what I want to do is to fill in the the figures for my base and my height. I will have half times my base being 24 cm and my height being 8 cm. Alright, so that would give me a grand total of 96 cm square. And this is my answer for question number 13. Alright, moving on to question number 14. We have an angles question over here. Let's read the question together. ABCD is a rhombus. Okay, I'm gonna stop my first sentence over here. Firstly, I want to note down the properties of a rhombus. What are the properties of a rhombus? All sides are the same. Opposite angles are equal. And lastly, they have two sets of parallel lines. So what I want to do is to label that on the figure itself, knowing that these angles, okay, ABC and ADC are the same. Also, DAB over here and DCB are the same. Alright, and also lastly, to note that line AB and line DC are parallel. Line DA and line CB are parallel. Alright, let's move on to the next sentence. It says AEC is a straight line. This line right over here is straight. Alright, and lastly, the question that is posted to us. Find angle DEC. Where is my DEC? I am going to label it with another color, something that is different. Okay, DEC is this angle over here. Alright, and that is what we want to find. Now we have two angles given to us right off the bat. We have this 50 degrees over here and this 78 degrees over here. Looking at point number 2 of my rhombus, opposite angles are equal. I know that angle ABC equals to angle ADC. Alright, knowing that, I can find angle EDC. How am I going to do that? I'm going to take 78 minus 50. Because they are equal, I can find this angle over here, right? Which is equals to 28 degrees. Next, what do we want to do? I want to use something called C angles. Alright, what is C angles? C angles just tells me that when I have two sets of parallel lines, the interior angles adds up to 180 degrees. Alright, so this angle over here and this angle over here will add up to 180 degrees. Now on the figure, where is the C that I am going to use? I'm going to highlight in green right here. From here all the way to here, all the way to here. And I want to know that this angle, alright, which is my 78 degrees, plus this angle here, DCB, would add up to 180 degrees. So from here, I can say that angle DCB equals to 180 degrees minus 78 degrees. And that would give me 102 degrees. Now, whenever I have a line cutting through a rhombus from one opposite angle to the other, I know that the two angles that are formed, which is this one over here and this one over here, are equal. And if angle DCB is equals to 102 degrees, I can find ACD. Angle ACD would just be 102 degrees divided by 2. That will give me 51 degrees. Now lastly, I'm going to use something called sum of angles in a triangle adds up to 180 degrees. Looking at triangle DEC, I can find angle DEC. Angle DEC equals to 180 degrees minus 51 degrees minus 28 degrees. And that would simply give me 101 degrees. And this is your answer for question number 14. Alright, moving on to the last question of booklet A. Question 15. Let's jump right in. Figure 1 shows a parallelogram with a perimeter of 50 cm. Alright, this is sentence number 1. I know that my perimeter for this equals to 50 cm. Alright, moving on to sentence number 2. Figure 2 is formed using 3 such parallelograms and it has a perimeter of 108 cm. Now, they're asking us to find the length of AB. Now, what I want to do from here, right, is actually just to multiply the perimeter of figure 1 by 3. Alright, so I have 50 cm times 3, that will give me 150 cm. When I have 3 of figure, I'm just going to draw it right here. Alright, I'm going to have this figure over here. And you realize the only difference between figure 2 and this 3 times of figure 1, right, is 2 times of this, 4 times of this, 6 times of this. So what I'm going to do is just to subtract them. Alright, so I will have 150 cm, which is 3 times of figure 1, minus the perimeter of figure 2, which is 108 cm, and that would give me 42 cm. What I'm going to do from here, right, is actually just to divide it by 6, right, because I know that 42 cm consists of 6 of these small edges over here. Right, so 42 cm divided by 6 would give me 7 cm. And that is my answer for question number 15. Thank you.
Hi everyone, if you like this video, you can click right here for a similar video or you can view our playlist here.